Alrighty, so we're trying to troubleshoot this severe clean ultrasonics unit at Mount Home Air Force Base in Idaho for the armament shop. So first thing we're going to do is going to turn on the main power circuit breaker. Then we're going to go back here. So we have, just for note, we have the control unit out for troubleshooting, which normally goes up there. But obviously the generators are not on yet. We're having a generator fault, which means one of these is not turning on. And we believe these are good, and we'll walk through this. So he's going to go ahead and turn the main power on, which obviously lights that up. That would normally be up in there, but we have it down here. So now he's going to hit the generator button, which is normally the top one there, which is on there. If you look, the bottom generator's on. You can hear him working, but if you look in here, so now what we're going to do is we're going to go ahead and turn this back off. So we're going to hit this button. We're going to turn the power off up here. I'll turn the circuit breaker back off just for safety. And then what we're going to do is we're going to swap the power cords going to that outlet. Just to make sure. So he went ahead and swapped those power cords going to that outlet there. So go ahead and turn the circuit breaker back on. Turn the red dial back on. Then he's going to hit the power button on the board. And now the top one works. As before, the bottom one worked. So now that's what's, turn that back off. So that tells us both of these generators are working as advertised. So then we're like, okay, is there an issue to the receptacle? So the receptacle, there's 120 and 120 going in to get your 240, because this whole board is 240 volts. We're going to go ahead and swap Gen 1 with Gen 2, both 120 leads, and that'll see if either if our fault will stay on Gen 1 or if it'll move, and we'll go from there. Alrighty, so what we did there is he swapped Gen 2, sorry it's hard to see in here, Gen 2 to Gen 1. He swapped these two wires, moved them over here, these two moved them over here. So now we're going to go ahead and turn on the circuit breaker again. So go ahead and turn on the main board, which turns that on. You go hit power, and now the bottom one works as before the top one works, which is expected. That tells us that that board is good. All right, so the circuit board's all, the test we did was in the machine, but we can't film when it's in the machine. So just to show you some of the stuff that we did, I'm just gonna have to imagine this. So this is the Gen 2, which is the good circuit. This is Gen 1, which is the bad circuit from all the previous footage we just showed you. These are the transistors that are controlling that. So when we first came out here, we were troubleshooting it. We got 120, 120, 120, and then this one, we had 120, 96, and 120. So we replaced this transistor and replaced this one with the same exact part number. Because in the past we've had some issues with these transistors. So we replaced those, same part number and everything. But, so we know that's all good. We checked these capacitors, these resistors, the fuse, all this stuff checked good separately and through the whole circuit, from good to suspected bad. We also had 120 on this leg, 120 on this leg, AC, 120 AC, 120 AC, which gets your 240. We know these fuses are good because we check continuity, and the 120 on both sides of the fuse, so we know the circuit's good. Then you come up to these dips, dual inline package, which is a switch. We know that this one is a good circuit, and this one is a suspected bad. So this right here is the input. We think it's the input, we're not completely sure, but there's a tracer that goes underneath this board that goes up to this, and this control ribbon cable goes to the controller. This one here goes over to this pin, which is a suspected bad one, and this goes up to the controller. So what we did on the board before we went to the controller is we checked on the back side of the dips. We got with it on, with the, if you look over here, with this dial on, but not the button pushed, or if we even pushed a button, we still got 120 volts AC, 120 volts AC, 120 volts AC, 120 volts AC. On the other side, because it's coming from the DC input of the controller, I would think it goes for like a rectifier bridge. It's a capacitor resistor. With it on, we got 9.9 volts DC, 9.9 volts DC. And of course, there you're going to get 9.9, you're going to get 9.9 over there. And then on this side, with the suspected bad one, with the red dial turn, we got 9.9, 9.9, 9.9 up to the controller. And I can show you the controller in the next part of this video. But when we turn the controller on, this one we got still 9.9, 9.9, 9.9, and then over here we got our voltage drop of 8.6, which is the same tracer. We got 8.6 with the controller on going to this. So out of all this testing, we showed in the video and the stuff we've done, all this stuff circuit we believe is good. The only anomaly we have is this is 9.9 with the circuit on with the controller, and then this one is 9.9 when it's turned off, but then as soon as you turn it on, you get the drop of 8.6. So let me go over that again because I might have talked a little fast on that one. Main power button on, 9.9 volts, 9.9 volts. Turn the controller on, 9.9 volts, and then it's when you got an 8.6 volts. So we got a voltage drop, which goes back to the controller, and we'll show that in the next part of the video. So we're trying to figure out which part of the board or which circuit is bad, or if there's another input, or what's going on from there. So the next part of the video will show the controller testing. Also, I forgot to mention, you know, we have the red lights you've seen in the video. We do have an aux2 LED lights going on too, but we checked the voltage, the 9.9 and all that stuff on both the dip, just like we've explained over here, and on the controller, and all that stuff's the same. The only thing we know about aux2 is that the LED lights are on. So, we'll show you in the next part of the video, the controller. All right, so I'm gonna turn the power back on. Go back down to here. We're gonna set this to voltage DC because the controller is controlled by voltage DC. I'm gonna go ahead and put my ground in here. I'm gonna use a piercing probe just to get into the board. I'm not gonna actually pierce into it. And then I'm gonna turn this power back on. Then I'm gonna come over here. And right now, I know that the fourth pin up is the bad one, meaning that's the fourth pin up right here, which goes to this circuit here, through this resistor, through this transistor, resistor, and diode. That's Gen 1, that's the one we're having the fault with. The fifth pin up on the inside, 3, 4, 5, this one is going to Gen 2, which is the good one. So if I turn this on, everything hooked up, we'll look right here, fourth pin up, this wire going in, goes to the bad side. Let's just compare data to the good and the bad. Right here, we'll go actually right here. If you look at the DMM, I got 9.9 volts. On the good, I go to this resistor, 9.9. I go back, I go to the other side of the resistor from the transistor, got 9.9. Now let's go to the bad one. This is with everything on. And just show them up here. Obviously, the bottom one's working. We've got our wire switched in there, which wouldn't matter for this test. But you go to the bad one, the fourth one up. You get my. I got 8.6. I don't have 9.9. I go to the resistor. Voltage drop. I go to the other side of the resistor, and then before I had 9.9. Watch this. I turn this back off. Power still on, but off. On the good one, 9.9. I go to the left side because I was just on the right, 9.9. I go to the right side of the bad one, suspected bad, 9.9. I go to the left of the suspected bad one, 9.9. And watch that gauge. If you can go back on the multimeter. I'm going to turn it on and I'm going to have a voltage drop, which I should not. Negative 2.4. Right, move the multimeter there, that's why I went to 0. This is the one that has a voltage drop. It's at negative 2.4. And up here on the good one, I should have 9.9. Every other one of these, I get 9.9. I'll show you one more here. I'm not going to go through every one. But I get 9.9. Except on this one, I get a negative voltage drop. I'm going to go on the other side of it to that pin. I don't know if it's with the circuit board sending if it sends or receives the DC voltage, if that's the issue, or if it's actually in the main board.